What is object-oriented programming from a developer point of view? Primitive data types are single and basic values. Examples are boolean, byte, char, short, int, long, float, double. They are considered the building blocks of data manipulation. They are predefined by Java. Programs in the past were not hard compared to the past. As programs become bigger and more complex, using primitives wasn't easy enough. The structure stores many pieces of data, can store different types of data. Structure can store structures within it. The array stores many pieces of data, can't store different types of data. Objects are instances of a class like a pencil, apple, book, bag, and a board. I'm reading. Classes are templates for objects. Class in computer programming. A button could be a class. These are like different data types within a class. These are like the different functions within a class and so many things. Classes provides means of bundling data and functionality together. Creating a new class creates a new type of object, allows new instances of that type to be made. Each class instances can have attributes attached to it before maintaining its state in class. And class instances can also have methods defined by its class for modifying the state. Encapsulation refers to the bundling of data with methods that can operate on the data within the class. It is a concept of hiding data within a class, preventing anything outside that class from directly accessing or interacting with it. It doesn't mean that members of the other classes can interact with that at all with attributes of another object. Members of other classes can interact with characteristics of other objects through its own methods. Methods, functions defined within a class. Accessor methods are getter methods that get global variables of a class. Mutator methods are setter methods that set the global variables of a class to a specific variable. Global versus local variables. Global variables can be accessed anywhere in the class. Local variables, only specific functions can access it. Access modifiers. Public. Any class can access it. Private. It can only be accessed within the class itself. Protected. Only related such based or derived classes like the parent or child classes can access it. Static. The object and variable or function that can't be modified and an object isn't needed to be used when calling the function. Abstraction. Only showing important and necessary details and keeps everything else hidden. A class follows a has a with another class word. Abstraction allows programs to be worked on incrementally and prevented from being entangled or complex. Interface and implementation. The interface refers to ways a section of code can communicate with one another. This is typically done through methods that a class is able to access. The implement of these methods or how these methods or code should be hidden. If classes are entangled, then one change creates a ripple effect that causes many more changes. Creating an interface through which classes can interact ensures that each page can be individually developed. Inheritance. The principle allows to derive information attributes from other classes: base class, parent class, derived class, child class. A class follows is a with another class approach. Any derived class objects would require the methods and attributes to be present in the base class in order for it to function. Polymorphism. Methods are able to take many forms. Dynamic polymorphism. Dynamic polymorphism occurs during the runtime of the program. This type of polymorphism describes a method signature with both a subclass or superclass. Method overriding. The method shares the same name but different implementations. The implementation of a subclass and the object is an instance of overrides that of the subclass. Kinsmore. Static polymorphism. It occurs in a compile time rather than runtime. It refers to methods with the same name but different arguments are defined in the same class. Method overloading. The method of being the same with different parameters and signatures. Names and objects. Objects have individual and multiple names that can be bound to the same object. This is known as aliasing with other classes. This is usually used to benefit of the program since aliases behave like pointers in some respect. For example, passing an object is cheap since only a pointer is passed by the implementation. If the function modifies an object passes an argument, the caller will see the change. Class definitions. Like functions, definitions must be executed before in any effect. In practice, a statement inside a class definition will be used by functions and other statements allowed is sometimes useful. The function definition inside a class normally have a specific form of argument list dictated by call conventions for methods. When a class definition is entered, a new namespace is created under used as a local scope. All assignments to local variables go in this new namespace. Class syntax. When a function binds a name of a new function here, when a class definition is left normally via the end a class object created. This is basically a wraparound content of the namespace created by the class definition. The original local scope, the one in effect just before the class is defined, was entered and is reinstated, and the class object is bound here to the class name given in the class definition header. Thank you, Kush. People could come. Yeah. What was the... What does it mean? Yeah. No. Class objects are supports two kinds of operations. Attribute references and instantiation. Valid attribute names and all names in the class space when the class or object would create. Class instantiation uses function notation. Many classes like to create objects with instances and specific instance objects. The only operations understood by instance objects are attribute references and data attributes need to be declared like local variables. They spring into existence when they are first assigned to. Method objects. Usually a method is called right after it's bound. The specific things are the specific thing about method is that object is passed as the first argument of the function. No, can't. Class variables are for attributes and methods shared by instances of all classes. Instance variables are for data unique to each instance. No. Very good. Oh. Class and instance variables share data that have possibly surprising effects with involving mutable objects such as lists and dictors. The trick list in the following code should not be used as a class variable because it's just a single list would be shared by all dog instances. The correct design of the class should be an instance variable instead. Inheritance, the name base class defined must be defined in a scope containing the derived class definite. In place, a base class name or other arbitrary expressions are allowed. This could be used, for example, when the base class is defined in another method. Derived classes may override methods of their base classes. Method references. This correspond class attribute is searched descending down the chain of base classes if necessary, and the method reference is valid if it yields a function object. Ryan Phil. Multi-inheritance. For most purposes and for many purposes, you can think of search after inherited from a parent class or depth first, left to right, not searching twice in the same class when they're overlap in hierarchy. Private variables, there's a valid use case and like for class methods, namely to avoid classes of names with names defined by subclasses. There's limited support for such a mechanism called name mingling. Name mingling is helpful for letting subclasses override methods without breaking inter-class method calls. Iterators. The most container objects can be looped over using for a for statement. This style of access is clear and concise and convenient. Having seen the mechanics behind the iterator protocol, it is easy to add an iterator behavior to your classes.